Good afternoon. I would like to thank the ICDTDE 2025 Organization Committee for giving us the opportunity to present our study findings. Mr. Nunkoo will be presenting the study on the adoption of innovative project quality management systems in the construction industry in small island developing states from a TAM-TOE perspective.
This presentation is structured as follows. I will begin with an introduction followed by the problem statement and justification. I will then review both studies and present the theoretical model and hypothesis developed. Next, I will explain the methodology used and approach to data analysis. The presentation will then cover the findings and discussion. Finally, I will conclude with the key conclusion and recommendation. The construction industry represents 13% of global GDP. By 2030, its value is expected to increase by 85% to reach $15.5 billion globally. However, the industry is still plagued with consistent quality issues, including delays, cost overruns, and defects. Hence, this study focused on how innovative project quality management system can change the construction sector positively. Quality management consists of systematic procedures and policies that are designed to ensure adherence to established standards and specifications. It includes planning, control, assurance, and continuous improvement to be able to reduce rework, avoid project delays, and also to mitigate defects. Despite its importance, several factors affect quality management in Mauritius. Firstly, the construction sector in Mauritius is among the least digitally advanced in the world. Additionally, traditional framework depend mainly on manual inspection, checklists, and paperwork. Also, quality management is mostly reactive instead of proactive. Based on these challenges, this study was guided by the following research question. What are the factors affecting the adoption of innovative project quality management systems in the construction sector in Mauritius? The potential of innovative technologies identified from past research for project quality management are shown in the table. Machine learning, which used predictive quality analytics to analyze historical data and forecast quality issues. Computer vision, which was used in automated visual inspection, where AI-powered systems detect defects through image or video analysis and thus improving accuracy and speed. Furthermore, robotics and automation, which use AI-driven robots to handle repetitive quality inspection tasks, thus reducing human error and improving efficiency. Also, building information modeling could be used as a way for automated design review that ensures compliance with regulation, detect conflicts or clash in building systems, and monitor construction projects as well as any deviation from project plans. Finally, digital twins could be used for simulation and monitoring to create virtual replicas of physical assets to predict failures and optimize quality assurance. After analyzing several theoretical frameworks for the adoption of innovative technologies, this study combines the Technology Acceptance Model (TAM) and the Technology Organization Environment Framework (TOE) to develop the hypothesis on the factors influencing the adoption of integrated project quality management system. Technology acceptance model focuses on important user-related criteria including perceived usefulness, perceived ease of use, and behavioral intention. Technology organization environment framework expand this perception by incorporating external factors such as industry influence, relative advantage, and compatibility that impact the adoption of new technologies at organizational level. hypotheses developed are as follows. Hypothesis 1A. Technological factors positively influence PEOU of IPQMS. 1B. Technological factors positively influence PU of IPQMS. 2A. Organizational factors positively influence PEOU of IPQMS. 2B. Organizational factors positively influence PU of IPQMS. 3A. Environmental factors positively influence PEOU of IPQMS. 3B. Environmental factors positively influence PU of IPQMS. 4A. Personal factors positively influence PEOU of IPQMS. 4B. Personal factors, including trust, mindset, and culture, positively influence PU of IPQMS. Hypothesis 5. PEOU positively influence attitude towards IPQMS. 6. PEOU positively influence PU of IPQMS. 7. PU positively influence construction professional attitude towards IPQMS. 8. PU positively influence construction professionals' intention to adopt IPQMS. 9. Attitude towards innovative technology positively influences professionals' intention to adopt IPQMS. This slide presents the proposed theoretical model for the study. The model illustrates the use of TOE and TAM, as previously mentioned, to understand factors influencing the adoption of integrated project quality management system. Moving on to the methodology adopted, the research design for this study consisted of a cross-sectional quantitative method. A survey using structured questions with 5-point Likert scale were used. 107 professionals were selected through convenience and snowball sampling. The quantitative data analysis was then done using SPSS software. Now let's dive into the core of our findings. The data of the 107 participants are illustrated in descriptive statistics. The reliability of each variable was confirmed using Cronbach alpha. The technique to test the hypothesis was simple linear regression, which was used to test the relationships between the independent and the dependent variable for the theoretical model. Additionally, to assess the barriers, relative importance index method was used to rank the items. The table shows the regression results and the p-values. Two hypotheses were not supported, namely hypothesis 1A as technological factors showed no significant influence on perceived ease of use, and hypothesis 3A as environmental factors were not significantly related to perceived ease of use. However, all other hypotheses formulated were supported, with p-values for all the variables being less than 0.05. This slide illustrates the final model developed. The barriers were identified and ranked using the RII method. The results showed that high initial investment and reluctance to adopt new technologies are the two main barriers for both public and private sectors. This finding was in line with Rana and authors who observed that many organizations in developing economies are still resistant to change and are slow to embrace new technologies even when there are clear benefits. In the public sector, organizations also worry about unclear return on investment and whether the benefits are real. For the private sector, cybersecurity and legal issues are two major worries. These findings were in line with Singh and authors who found that exploitation by hackers, cybercrime, and privacy intrusion were among the most influential barriers to AI adoption in construction supply chains. To conclude this study, several critical factors were identified for adoption of innovative project quality management systems in the construction industry. Firstly, construction projects are prone to failure due to lacking quality control. Hence, robust PQMS need to be developed using innovative technologies to improve construction workflows. This study emphasized on the factors that influence the adoption of innovative PQMS. This can provide insight to policymakers, public and private organizations who can focus on the most influential factors and encourage the use of IPQMS. Moreover, adoption is hampered by high costs, cybersecurity and legal issues, as well as resistance to change. These barriers will need to be addressed by policymakers in terms of incentive, new legal frameworks, policy changes, and investment in building capacity. Also, the study showed that adoption of IPQMS will require dedicated leadership, resources, and training to overcome hesitation and instill confidence in the system. Confidence in the system can be developed through phased adoption, which can begin with the use of pilot projects tailored to the corresponding level of capacity to impact positively personal factors such as trust and work culture. For researchers, it is recommended that longitudinal studies are carried in companies comparing projects being carried out using traditional methods and using IPQMS to assess potential benefits. Hence, it can be concluded that IPQMS has the potential to improve the quality and efficiency of projects in Mauritius. However, the use of such technology will depend on the organization, leadership, and personal behavioral patterns. These need to be addressed both in the public and private sector to ensure improved project delivery success rates. That concludes the formal presentation. Thank you for your time and attention.